Continuing on with our discussion of intermolecular forces, the next one we're going to look at is called dipole-dipole attraction. So before we can talk about this intermolecular force, we need to know what is a dipole. So if I have the molecule HF, remember that this denotes a covalent bond, which is the sharing of electrons. Now, around this molecule is something called the electron cloud. Around every molecule, there is this electron cloud, but what we need to know is that this is not distributed evenly in a molecule. This is going to be lopsided based on an atom's electronegativity that make up the molecule. So fluorine from the table is the most electronegative atom on the table. So fluorine is going to want this electron cloud much more than hydrogen does. So what I like to do is sometimes denote a little electron cloud. It doesn't have to be perfect. So if this were both the same atoms, we could draw it symmetrical like this. But because fluorine wants that cloud much more than hydrogen does, it looks more like something like this, where fluorine really hogs that electron cloud. Now, how we denote this without having to draw this big picture is that fluorine, now it does not have a full negative charge like a molecule like, or an atom like Na plus and Cl minus. These are full negative charges. That is not the case here. All we do is denote a partial negative charge. And then hydrogen would have a partial positive charge. So it's really important to know that fluorine really wants this electron cloud, and that although it doesn't have a full negative charge, it has a partial negative charge to denote that it's getting more of that electron cloud than hydrogen. So that creates what is called a dipole, which is this uneven distribution of the electron cloud in a molecule. Now, what happens when HF comes together with another HF? Well, fluorine, just the same, will want the electron cloud over here, creating a partial negative charge, and hydrogen will have a partial positive charge. And what we can see is that each of these two separate HF molecules have their own partial positive and partial negative charges. And then when we bring them together, this is an intermolecular force created between the partial negative and partial positive. Remember, positives and negatives attract. This is an intermolecular force called the dipole-dipole interaction. Right? So just to recap, a dipole is an uneven distribution of the electron cloud. The more electronegative atom is going to take more of that cloud, creating this partial negative and partial positive charge. When we have two molecules, both with this dipole, we can create a dipole-dipole interaction, which is an intermolecular force.